So we're looking at equations and graphs of polynomial functions, and you have a graph similar like this in your handout, and example 1 says the following. It says, for each graph of a polynomial function, determine 1. The least possible degree and the sign of the leading coefficient, 2. the x-intercepts and factors of the function, and 3. the intervals where the function is positive and the intervals where it is negative. So let's just start examining this graph. So let's start looking at example 1a, and first let's look at the least possible degree. So you look at this graph and we know that it crosses the x-axis at 3 points. So we know that at least this has to have a degree of 3. So let's write this down as the answers. Least, let me take over. Least possible degree, we're gonna say it's 3, right? Least possible degree, it's 3. Okay, it crosses the x-axis at 3 points. The next thing is the sign of the leading coefficient. So if we know that it's an odd degree function and it starts on quadrant 2 and ends in quadrant 4, then immediately we know that the sign of the leading coefficient, is going to be negative, right? Because we see that begins from quadrant 2 to quadrant 4. If you need to review the previous videos, you should do so. Next, it says find the x-intercepts. Okay, so now we can basically look at these. So we have x-intercept of x equals to -5, x equals to 0, and x equals to 3. So let's collect that data here, and it says x equals to -5, x equals to 0, and x equals to -3. Okay, that's a 3. That's a -3. Alright, and oh, sorry, not -3, it's actually +3. I made a mistake. This is 3, +3. Okay, and then the next question says the factors. Okay, well, we basically, if these are the x-intercepts, then our factors are going to be x plus 5 brackets x minus 0, which is basically x, and then x minus 3. Okay, and the next question says find the intervals. Now, in order to find the intervals, let me move this up a little more so we can have some space. Basically what we're looking at is how the function behaves between these intervals. So in this case, between infinity and -5, and then also between -5 and 0, how the function behaves between 0 and 3, and then also 0 to +infinity. So in order to answer that question about the intervals, I suggest you make a table that looks like such. So you write intervals here. I hope you can see it. Yes, intervals. And then right below we're gonna say sign of the function f of x. So sign of f of x. Okay. And then of course we start putting here our intervals. So as we said before, from -infinity to -5. So -infinity to -5. Right? If you need to review interval notation, you should do so right now. The next interval is from -5 to 0. So we start from -5 to 0. Right? We're going to see how it behaves there. Then from 0 to 3. So from 0 to 3, and the last one from 3 all the way to +infinity. So from 3 all the way to +infinity. Okay, so now by looking at the graph, let me move this up a bit, or by looking at the graph from -infinity to -5, -infinity to -5, f of x is going to be positive. We see that this function exists above the x-axis, so we simply put positive here. Right? Now from -5 to 0, f of x is negative, is below the x-axis, so f of x turns out to be negative, so we put negative here. And then from 0 to 3, we can see that it goes over, right, the x-axis, so it's positive. And then from 3 all the way to positive infinity, it will be negative. So yes, that's how we answer these questions. So let's look at example B on our next video.